All right, so last week you learned some integration techniques. You learned the substitution approach. You learned integration by parts. And pretty much for most of the problems you've done, either you use the substitution to help you find the antiderivative, or you use integration by parts to help you find the antiderivative. But here's where we have a situation where the integral is a little more complicated. So we're looking at the integral from 1 to 4 of e to the square root of x dx. Now, what makes that integral complicated? What is making that integral?
The square root of x.
That's correct. That's right, Peter. Square root of x. So what we should try to do is we should let u equal the square root of x and see what happens. In other words, convert this integral, which is respect to x, convert it to an integral with respect to u, and then see what happens. So I'll show you how we do that then. Here we are. I'm going to let u equal the square root of x. We are going to let u equal the square root of x. So u equals x to the half power. And so now in the integral above, e to the square root of x is now e to the u. But the question is, what about dx? What's that going to become? And also, we do have to convert these x limits of 1 and 4. But let's focus on dx. So, all right, u equals x to the half. This means then that du dx, take the derivative of that function, and you'll get 1/2 times x to the negative half power. Right. Well, all right, so I want to get the du, well, I want to multiply both sides by dx, okay? I want to multiply both sides of that equation by dx, okay, which I do. And you're going to get then some simplification here. And so du will equal 1/2 times x to the negative half dx. But we want to get the dx by itself, right? We want to get the dx by itself. So what I have to do is I have to multiply both sides of the equation by x to the half power. Now, why is that? Because if you have on the right side, if you have x to the negative half times x to the positive half, that'll equal x to the negative half plus half power. That equals x to the 0 power. We add the exponents when we multiply, and the bases are the same. Negative 1/2 plus 1/2 is 0. And that x to the 0 power just equals what? What is x to the 0 power?
1.
It equals 1. So now we have then, well, now remember, x to the half was equal to u. So on the left side here, we have u du. And then on the right side, we have 1/2 times 1 times dx. Okay, so I mean, I don't think I need to put that there, but x to the 0 power is just 1, right? So now, you know, again, we want to get the dx by itself. So now what I'm going to do is I'm going to multiply by 2 on both sides, and so then dx equals 2u du. And now we know exactly what that dx is. So dx is 2u du. And so this integral now, this integral with respect to x becomes this new integral with respect to u. The u limits are going to be 2 and 1. So remember, u is the square root of x. So the top x limit was 4. Well, the square root of 4 is 2. The bottom x limit was 1. The square root of 1 is 1. And so this gets us here. And I can factor that 2 out, right? Let me stop for a minute and give you a moment to think, and please let me know if you have any questions.
I had a question. So how did you get from x to the x 1/2 du equals 1/2 x to the power negative 1/2 x 1 to the power 1/2 dx?
You're talking. Is it this step here?
It's this one right here.
Okay. Yeah. Show me there. That one. So I want to get the dx by itself. So I can't have. I want to get the dx. Hold on here. I want to get the dx alone. So this x to the negative half, I have to remove it. Well, if I multiply, I mean, this is an equation. If I multiply by x to the half power on the right side, and I have to do it on the left also, but if I multiply by x to the half power on the right side, then why do I pick x to the half? Because x to the half times x to the negative half is x to the 0th power. And x to the 0th power here just equals 1. So you see there's no more x term on the right-hand side. If I had x to the negative 3rd, instead of x to the negative half on the right-hand side, I would multiply by x to the positive 3rd. Okay? I'm just doing what I need to do to find out what dx equals in terms of the variable u. Okay. Well, I hope that helps. And so here we are. We have 2 times the integral from 1 to 2 of u times e to the u du. And well, okay. How am I going to do this integral here? How am I going to do that integral? What approach am I going to use to get the antiderivative?
Integration by parts.
That's right, Clea, integration by parts. So let me go to the next page then, and let's do integration by parts on that. So, you know, here's our integral. Now, you know, the integration by parts formula is, as you know, the integral of u dv equals uv minus the integral of v du. But I already have a variable u here in my integral. So let me just adapt a new integration by parts formula. I mean, it's the same formula, but where I have u, yeah, let me one moment here. Where I have u, I will go back, Mandy, but let me just finish up the problem and then I'll go back, okay? Don't worry. We'll have an opportunity to go back. You know, if I were to, again, I want to have a different integration by parts formula. Okay. I'm not saying this the right way, but the integration by parts formula that I'm used to has a variable u in it. And I already have a u in my integral. So instead of the integral of u dv, let me do integral of w dv. Okay, because the integral has no w's or v's in it. So let me replace everywhere I see a u. Let me replace the u with a w in the integration by parts formula. du would become dw. Okay, so now this is a acceptable integration by parts formula. The integral of w dv equals wv minus the integral of v dw. That's acceptable. And I'm going to let w equal u, and I'm going to let so w will equal u, and I'm going to let dv equal e to the u du. Okay, and so I'm starting here on the left-hand side of this integration by parts formula. Mohammed, question?
Yeah, I was just a little confused as to why you did u substitution before the substitution by parts.
If you did integration by parts on that original integral, you would wind up with a real mess.
Okay, so it's just
You
to
can
like
try it.
simplify it, basically.
And it may not, hold on, let me turn, I don't want this email on. I don't want to have noise here interrupting us. Okay, yeah, I'm not saying it wouldn't work, but I don't think it would work. I think you're going to end up with something that you can't do anything with,
Okay.
So like for the section 5.6 exercises, okay, these new exercises that you're going to have due on the Friday there for the 5.6, those exercises are ones where you're going to be making a substitution and first, and then you're going to be doing integration by parts. It'll just work a lot more easily. I'm just double checking to make sure that should be accurate. Hold on one moment. Just give me a moment here. One moment here. Hold on now. Give me a second here. Okay, sorry. Just give me one moment. Okay, that's fine. Mohammed, so let me ask you this. So e to the square root of x is complicated. So wouldn't intuitively you might want to make that e to the u if you could by substitution? Wouldn't you want to start off that way?
Yeah, wouldn't you just also be able to do like e to the x to the 1/3 and then use x to the 1/3 as u?
Well, we don't. We have e to the x to the half power.
Oh, sorry. Yeah, half power. That's what I meant.
Yeah, well, that's what we did. We let u equal x to the half power. And I guess while I'm back here, Mandy, this is the page you wanted to see, right? So let me stay here for a moment to make sure Mandy's comfortable too. Fair is fair, right? But yeah, Mohammed, yeah. You would not want to, want to do integration by parts directly on like this integral. You don't want to do integration by parts directly on that.
Okay, got it.
All right, Mandy, are you very good? Mandy, are you good?
Yes.
And sorry,
Okay, next.
for the second page you were on, were you substituting by parts like twice? You had two separate substitutions?
Here, well, what I did on this page here, because my integral has a variable u in it, I get kind of confused if I were to use the first formula. You know,
Oh, okay,
it
okay, got it.
yeah. So I tweak that formula to instead of I replace the u with a w,
Okay, got
so
it.
that then I can let w equal u
All right,
and
cool. Thank you.
dv. All right, and you know you've done integration by parts, so you know you do the integration by parts, and now this e to the u power, okay, that is something that is very nice to work with. You can get its antiderivative, and you're good to go. You're good to go. Of course, when you do integration by parts, the limits don't change. When you do a substitution, you change the limits, but integration by parts, you don't change the limits. And I'll make another comment too while I'm at it. I think it's just worth commenting. Let's suppose that you had said, okay, I'm gonna let W equal e to the u, and I'm gonna let dV equal u du. If you did that, then dW would equal e to the u du, and V would equal u squared over 2. So then integration by parts, what you would get, let me just, one moment here. Yep, that's right. So integration by parts, you would get e to the u times u. I don't want things to get too, hold on here, let me kind of separate. Okay, so integration by parts, you would get e to the u times u squared over 2 minus the integral of u squared over 2, you know, v dw, times e to the u du. That's what you would get. And you would know that there's a problem, right? Because how does this integral compare to your original integral? How does when you do the integration, again, if you let w equal e to the u and dv equals u d to the u, if you did it that way and tried to do it that way, well, you wind up with this integral. Is this integral here harder or easier than the integral you started with? How would you describe the integral of u squared times e to the u over 2? Is that harder or easier than the integral you started with?
Harder.
Harder. That's right, Susanna. So this is not going to work. That's not going to work. Okay. So how many had experience like that where maybe you did your integration by parts and you got something worse than you started with? Did anybody have that experience? Usually everybody does. Okay, Mark had. Okay, all right. So just to keep it in mind that you wanna wind up with an integral that's easier or at least no harder than the one you started with. And so this worked. This worked, and in the end you get 2 times e squared. So now, like in WebAssign, the homework, or on the exam, you would put in 2 times e squared. If you put in a decimal approximation, WebAssign will likely count it as wrong, and it would be wrong because we want simplified radical form. Okay, simplified radical form. Okay, are there any questions on that? Okay. Let me go to the. Let me go. I want to go to the whiteboard here and just do another one. Look at another kind of problem with you. It isn't the. I won't do it all the way out, but I'll at least help you get started with it. Okay, so let's go to the whiteboard here. Everybody's good? All right. Let's say that your integral I or equal to this integral, the integral of the sine of the log of x. This is another problem where you're going to want to make a substitution first. So what substitution would you make? What would you let u equal?
ln of x.
That's right. That's right, Clay. ln of x. Okay, so u would equal ln of x. So then here we now have the sine of u. And the question is now, what's dx going to be? Okay, well, so to get the dx into the mix, I have to take the derivative. So du dx will equal, what's the derivative of the log of x? You should all know that. Derivative of the natural log is, that's right, Jasmine, 1 over x. That's right, Javier. Good. That's right, Mark. And so du will equal 1 over x dx. Or you could say that x times du equals dx. So I got the dx by itself, but on the left-hand side, I have this x here. I got to figure out what that x is. Well, let's take a look at this u equals the log of x. If u equals the natural log of x, how can I get the x by itself on the right-hand side? What do I have to do to both sides of the equation? Well, Victoria, you're almost right. How about exponentiate both sides? I think maybe that's what you meant. Okay, I'm gonna exponentiate both sides of this equation. And that's going to then get me that e to the u equals, well, what is e raised to the log, natural log of x power equal to? What does that equal?
X.
X. And so now I got it. Now I got it. E to the u du equals d to the x. So after the substitution, this is our new integral, right? That's our new integral there.
Could you explain one more time why you put e into the
Well, so I have to figure out what x is in terms of the variable u. And all I have, the only relation, I mean, I have that u equals the log of x. So if I, on the right-hand side, that's where the x is. If I want to get the x by itself, I have to exponentiate both sides of the equation. Because, and that'll work because e raised to the natural log of x power just equals x. So x would equal e to the u. So that's what I had to do to find out what x is. And the reason I'm doing this one with you is I'm thinking probably, I think majority of you would know to do that eventually, but I'm just trying to show you, the more different scenarios you see, the better. Amanda, is that okay?
Yes.
Okay, good, good. Okay, so now you're here. Now you're here. And what are you going to do now? How are you going to find the antiderivative of e to the u sine of u du? What procedure are you going to use?
Integration by parts formula?
That's right. You're going to use integration. That's right, Victoria. Integration by parts.
So, Professor, I have a quick question.
Yes, Lillian.
For integration by parts, the dv, the derivative of dv, it's not the derivative. You're going to be taking the antiderivative.
For
Integration by parts, you would separate it with u and dv. For dv, you're not taking the derivative. You're taking the antiderivative.
well, in integration by parts, like for example, now this is not connected with this problem, but like if you had like dv equals x dx, then v would be the antiderivative of x, which is x squared over 2. So to get the v, you are taking the antiderivative. Now this is
Okay, you're
not
taking the
connected.
answer.
I'm sorry.
That's for all the problems. Am I correct?
Yes, all the problems. When you
So
do
you're
integration
taking
by parts, you have to take a derivative and you have to get an antiderivative. That's correct.
Okay.
To apply the formula. And I'm going to just kind of let you, you can finish this. I mean, you know how to finish it. A lot of times it's getting started with the problem that's the hardest thing. But are there any other good questions? Okay, I'll stop the recording then.